In labs all over the world, there's this quiet revolution happening. It's not about bigger machines or newer chemicals. Nope, it's about shifting from human hands to autonomous AI, and it's completely transforming the way we discover things. But this whole revolution, well, it all hinges on one critical element. And that's because every single breakthrough, every cure we find, is built on a foundation of data. And if that foundation is cracked, the whole thing can just come crashing down. This brings us to a hidden, but honestly an incredibly dangerous crisis that's happening in labs right now. And this is a crisis that's way more widespread and costly than most people even realize. It's not happening in beakers, but in spreadsheets and databases.
So when you think about a risk in a lab, what pops into your head? Maybe a volatile chemical reaction? A contagious sample? Yeah, sure, those are possibilities. But the most common and maybe the most expensive threat is something a lot less dramatic.
The single biggest risk is bad data. Yeah. A simple copy-paste error, a lost file, a slightly altered result. These are the silent killers of scientific progress. And this isn't some rare thing. It is an absolute epidemic. The scale of this problem is just staggering. Get this, in 2021, 61% of all warning letters the FDA sent out were because of data integrity issues. This is a massive systemic failure, and the consequences, they're severe. And look, the fallout isn't just theoretical. We're talking about real-world stuff. Years of research being invalidated, super expensive product recalls, life-saving medicines getting delayed, and, worst of all, patient safety being compromised. It's a huge drain that can literally cost a lab its license to operate. So right about now, you're probably thinking, wait a minute, don't we have software for this? And yeah, we do. It's called a LIMS, a Laboratory Information Management System, and it's supposed to track all this data. But for a ton of labs, especially the smaller ones, the solution has actually become part of the problem. This right here, this really gets to the heart of it. Nearly half of all lab workers are still using manual spreadsheets. Why? Because the traditional LIMS systems, the big software out there, are often a terrible, terrible fit for what they actually need. You see, here's the crucial mismatch. The old school LIMS are built like financial software from the 80s. They're enormous, super expensive, and totally inflexible. But a modern research lab, especially a small or mid-sized one, they're dynamic. They need tools that are agile, affordable, and can change on the fly as their research evolves. And believe it or not, it gets even worse. These old systems don't talk to modern lab equipment. So you have brilliant scientists manually converting files, retyping results, and just shuffling data between what are basically digitized islands. It is slow, it's begging for errors, and it's a colossal waste of brainpower. This quote just nails it. Labs are swimming in more data than ever before, but they're drowning when it comes to turning that data into actual knowledge. But what if we could change all that? Okay, so let's leave the frustrating present behind and jump into an incredibly exciting future. We're talking about a huge shift from software that just stores data to AI that actually participates in the research. This is the new paradigm right here, the autonomous scientist agent. It's not just another tool, it's a collaborator. Just imagine an AI that can help manage the entire research process, working right alongside human scientists from the very start to the very end. So picture this, you've got an agent that can sift through millions of research papers and all your past experiments to come up with new, totally testable ideas. It's like your tireless brainstorming partner. Then you have another agent that takes that idea and designs the perfect experiment. It'll draft the protocol, figure out the right sample sizes, and even check for safety risks based on your specific lab setup. And finally, after the data's been collected, you have an agent that analyzes the results, pulls out the key insights, and suggests the most logical next steps. It creates this perfect closed loop of discovery. And the impact of this? It's absolutely revolutionary. Look at these numbers. We're seeing research cycles that used to take weeks shrink down to days, or sometimes even hours. That means lower costs, way better use of data, and just a massive speed up in discovery. This isn't science fiction anymore. This is what's becoming possible right now. So the big question is, how do we get there? This incredible future needs a brand new kind of platform, and that's where a solution like LabABLE comes in. It's designed to be the operating system for the modern AI-driven lab. The way it works is pretty simple. Think of it in 3 layers. First, you've got a solid foundation for all the core stuff, like tracking samples. Then there's a connector layer that finally gets all your instruments talking to each other. And then on top, you have an ecosystem where the real magic happens.
And what's so great is that this directly fixes all those problems we talked about earlier. Instead of a painful rip and replace, you just plug it into what you already have. Scientists can build their own automations without needing to write a single line of code. And the subscription model actually works for labs on tight, grant-funded budgets.
Okay, now this is my favorite part, the marketplace. It basically works like a hugging face for science. Labs can share and download pre-built AI agents, workflows, and dashboards. You don't have to reinvent the wheel every single time. You can just build on the work of the entire community with a single click.
Here's another way to think about it. It's got the collaboration of GitHub mixed with the easy no-code automation of Zapier, but it's built specifically for how labs operate. It is an incredibly powerful idea.
And this is the ultimate goal, the real transformation. It's about fundamentally changing the economics and the speed of science, turning labs from these manual, slow cost centers into super efficient AI-driven discovery engines.
And that leaves us with one final big thought. When we get rid of all the manual bottlenecks and we give scientists AI co-pilots that can test ideas at a scale we've never even dreamed of, what becomes possible? The next great discovery might be just one automated experiment away.